Thank you. Again, I'm Kenny Burke, General Manager and Treasurer for the Groundwater Resources Board. For those of you that don't know the work that we do, basically we are a policy organization for the state of Rhode Island. We are charged with the regulation of the proper use, development, conservation, and protection of the water resources of the state. Fundamentally, the focus is fresh water, and directly it's with our major water suppliers. But as of late, we've branched out a little bit deeper, working more closely with agriculture, trying to reach out and anticipate future economic development opportunities as well. So as we're talking about going with the flow here, is there enough water for all of us? You know, my answer here, kind of tongue-in-cheek, is it depends. When I started just over 4 years ago, the first responsibility I had, actually within 15 minutes of being hired, I was told that I had to produce groundwater out of the Big River Management Area, 8,600 acres in central Rhode Island. And I said, absolutely, no problem. You know, didn't even ask why. About a year and a half later into the project, after none of the water suppliers wanted to buy any of the water, after I had a hard time building up a pro forma that made financial sense to do this work, we opted to take a closer look as staff to figure out functionally how we can get back to the board and have a robust conversation about the mission of the Water Resources Board. And it did actually come back to water quantity, which is really one of our focuses. It's not so much on the quality side. DM and health really have that firmly under control. So we've taken that conversation, and in Rhode Island, I mean, we're blessed with a small state. We have a very well-defined water supply system. This graphic shows you essentially the major water supplies in the state that are accounting for about 90% of the potable water supply consumed in Rhode Island. The dark green area up here is Providence Water Supply Board, the Situate Reservoir. The light green shows you the wholesale customers of Providence Water. I mean, in aggregate, that's better than 2/3 of the potable water supply consumed in the state of Rhode Island. Tremendous resource, absolutely tremendous resource. And again, just for clarity, that's the service area for those water supplies. The other tan areas are the other smaller water supply systems throughout the state that produce their own water. Some of them actually buy water wholesale through others, and a combination of surface water systems and groundwater systems. Next slide here shows a product of the Division of Planning statewide planning program. Nancy will probably talk about this a little bit later, but this is an urban services boundary. And again, I'm showing this as a means to communicate the availability of water, quantity of water. Statewide planning had produced this to identify in the darker shaded areas in the internal part of the graphic dense concentrations of existing development. The outside lighter pink boundaries basically shows the extent of the infrastructure for water supply. And if I toggle back and forth, you can see that these outlines emulate one another, and that's not by mistake. That's basically reflecting where infrastructure, streets, power, water basically are already centered. And it's a story of the state of Rhode Island, how it developed over many, many years. There's an interest at the Division of Planning to ensure that there's the proper development of the state as a whole, and that you don't have unrelenting sprawl in these green areas throughout the state. So in the future, what we're looking at doing is supporting the direction of the statewide Division of Planning and ensuring that major development happens within these urban services boundaries. There is an eye towards the future with these stars in the map, and that's an active project that is being looked at the Division of Planning as far as future build out and future growth in the state. So as again, I started looking at this Big River well project, didn't really seem to have a lot of support after we'd started doing the investigations. We as staff decided to step back and look at a strategic planning initiative where we basically give an overview of a lot of the data that we've collected over decades. And we employed a dynamic strategic planning process where essentially we try to be innovative, be solution oriented, Again, differentiating ourselves from maybe a full-on planning program. We want to come up with very tangible, real options for our board to understand and grapple with. Tried to pull forth some new ideas to really, again, engage the board and the community at large so we can actually do something, get things done. We employed this See, Think, Do tool, which is simply, we spent a lot of time out in the field. We visited every single water supplier in the state. We hosted board meetings at Save the Bay, Rich Shartner's farm out on off of 102, EDC, QDC. We're all over the place. We really reach far and wide to try to understand the folks that use water, how they use it, what was important to them. And we actually came up with a really neat palette of options that the board was able to consider as far as solutions to solving deficiencies of water quantity. And again, the result here is about 20 supply and demand initiatives that the board considered. So as we did a lot of number crunching, and I'm kind of going through this, there's a lot of information on our website that describes the detail. Kathy Crowley's in the back. She spearheaded much of the scientific research and compiled it all. But we asked 3 basic questions. We figured this is an easy way, and for those of you that deal with boards and commissions, I mean, it's herding cats, right? And there's no board members here, so I can say that, although it's on YouTube. I'm screwed, but that's okay. It was a method for us to have a communication with our board, a conversation. How much water is there in the state? How much water are we using, and how much do we need? We tried to get really basic here. How much water is there? That question we asked in May 2011. We used a convention of 1 million gallons a day, but basically 2 billion gallons of water flows through the state of Rhode Island, through the Blackstone, in and out of the state, ends up in the bay and down on the shore. Why is that number important? It's really not a useful number, but it's meant to provide a backdrop as far as the volume of water, the freshwater resources that actually are in the state of Rhode Island. Built off of decades worth of gauge data, both with stream gauge data through USGS, our groundwater monitoring stations, and our annual data that we collect from all the major water suppliers. And then how much water are we using? This was a compilation of, again, annual water use data from our water suppliers, the water use and availability studies that the Water Resources Board commissioned through USGS over the past decade. Very intricate accounting of water between different basins in the state. If you're ever looking for some brain damage, please pick up one of these documents. Be sure to please, if statistical references are just off the charts. Great information though. But basically the correlation is this. We're using about 1/10 of the water that flows to the state. Okay, 10%, all right? That's what it ends up being. And that's appropriate. I mean, we want to make sure that there's plenty of water in the system. I mean, water needs to be there for the environment. And we wanted to present it in a way that the board kind of understood proportionally how much water we are using as we're impacting the ecosystem. How much water do we need? That was a tougher conversation. We needed to essentially identify demand and understand how we define the demand. And what we did in that aspect is we looked at 2 parts of availability of water through conventional sources for water supply. One of them, which is not on this graph, is reservoir systems. That's a very straightforward engineering calculation. Reservoirs are supposed to be designed to withstand drought of record. It's actually a statute in Rhode Island general law. It's the 1960s droughts. It's about 2 or 3 years worth of very, very dry weather. And you look at the inflow, you look at the outflow, the water that you use to produce potable water. And if you can withstand a 3-year drought, well, that's the safe yield of that reservoir. That was the easy part. The harder part is looking at groundwater. And this is not unique to Rhode Island. It's actually been, it still is actively discussed all throughout the country, throughout the world, as a matter of fact. How much water do you leave in a stream? And what we did as staff is we worked very closely with DM. DM has done some amazing work for probably going on 10 years anyways, and they have developed what they call stream flow depletion methodology. And it's, I'll say simply, there's nothing simple about it, but it's simply a way to communicate a screening tool to allow anybody that wants to use water from a groundwater source or close to a stream source, allowing them a screening tool to gauge what type of impact they might have on that river or stream. And we looked at that specific methodology and compared it to some other well-known methodologies, aquatic base flow, Rhode Island version of aquatic base flow, the USGS, as you heard Mr. Verde just earlier talk about defensible statistical analysis of flow. They will stand by every statistic they ever produce. You plot all this stuff out, and the darker line up here on the graph basically shows you the actual flow. This is one of the gauges. I think this might be one down in the Chapuxet, but that's the actual flow. The highest peaking dark line is the flow of the river, and all these other variations of an allowable depletion or a sustainable depletion is essentially emulating that natural flow. And we took a step back because, man, the argument started happening. The farmers, the water suppliers, there's a beaver dam upstream. That's not my fault. You know, the low flow is through other problems with how the stream is managed. It doesn't matter. At the end of the day, we said an environmental ideal is to have the stream be as natural as possible. And we embraced that. We said that's our ideal too. We're taking the stream flow depletion methodology, we're taking that and we're building that into what we call, it's a working definition of the safe yield of a water resource. And when we did that, we were able to qualify how much water truly is available in all these groundwater systems. So after we'd gone through that analysis, and there's a lot of information that backs that up on our website, we then started looking at demand analysis, how people extract water out of the ground, farmers and irrigation systems. A nice shot of Narragansett Beach and all the peak influx of folks coming out to the South Shore. And then, you know, this graphic here, I didn't want to put a fire hydrant there, mixed signals there. But anyways, this is how humans use water. Okay, we need to have pressure in our tanks for fire flow. We need to keep the water moving through the pipes for health reasons. That defined our demand. There's an average demand and then there's the peak demand. We have to analyze both because the peak defines how you size your infrastructure, the pipes in the ground, the tanks that are up in the air. We aggregated that information and we're able to come up with 4 regions of the state to analyze, to talk about. Northern region, essentially, these are all surface water systems, reservoirs. Southern region, these are all groundwater systems. They're very dependent on how much precipitation is out there. Quinnic region, this is a surface water system, but highly vulnerable because you don't see major watersheds. It's a very small watershed. And then the islands here, they're the last region. They know their islands. They're very aggressive with their water management techniques. So we did our analysis and talked about how much demand was out there in each of these areas, inclusive of the self-supply as well. Came up with these numbers, and then we started crunching the numbers based on the safe yield, either surface water or the riverine systems based on our resource protection goal. What we analyzed and what we came up with is essentially in the southern region, you have not only a peak deficiency in the summertime, but today we have an average deficiency. These are actually build-out analysis, and it showed a substantial deficiency at full build-out. If you built out properties as they are currently zoned, you would have significant deficiencies. The northern region shows a summer peak deficiency, but that's a little bit, it needs explanation. Reservoirs are meant to sustain, dipping into your safe yield. It's meant to sustain basically a 3-year drought cycle. What we wanted to convey in analyzing that northern region deficiency is that in the long term, you really should look at alternative measures to back up that source. Okay, it's perfectly capable of withstanding 1 year's worth of additional 36 million gallons of depletion because it's built for 3 years of storage. The Quinnic region, they can manage their own, but they're highly vulnerable regarding where they are, right in the bay. The water quality needs a lot of treatment. And the islands, again, they can manage their own, but they're very unique. You're not seeing a lot of building out there, very aggressive in their water demand strategies. And for simplicity, again, working with the board, we put these big red dots on the map so they could focus on specifically where the water is coming out of the ground. So we could talk about specific initiatives to help solve some water supply, water resource equations. Now, what does it all mean? Well, where we are today is we've developed short-term strategies. We are focusing, if I go back to the Chapuxet right here, this is one of the largest deficiencies. It doesn't happen that often. I mean, we've got a lot of rain now, okay? But we're not planning for that type of condition. We're planning for the eventual dry season when you have a spike of tourism, you have a spike of water coming out of the ground. The agricultural folks, if it's dry, they're going to start watering their turf, corn, what have you. And this is what really drives a lot of our decision making. So we've got an agricultural efficiency program that we've developed. Ken Ayers is here. We worked really hard over this past winter to talk about building relationships with NRCS, DM Ag. Unfortunately, the program did not make it through the budget this year. We have an appliance and fixture rebate program that we're pushing forward. Again, it's not funded. An education program, we did work with Murder George and others. We are educating folks all throughout South County about demand reduction whenever possible. But equally important, actually more important per our statutory charge, is the long-term management options. And we are looking in this first bullet, regional water management plans, which actually is relevant regarding where the General Assembly was this past session and looking at a statewide regional water authority. That is a topic that will be coming up at the Water Resource Board at our next meeting, subsequent meetings, and then developing new sources of supply. We do, believe it or not, need to start protecting sources of supply, groundwater, and then have an eye towards the future for future surface water systems. And then again, some housekeeping is declarations of exceedance of safe yield is a trigger for statutes for us to actually take action. And then management tools for state agencies, municipalities are key. That's where development happens every day. It doesn't happen necessarily at a state level. It happens at each and every municipality. That is a requirement for us to work directly with municipalities. And then again, suppliers and farmers. So I did want to throw this graphic out there. That's my kid and that's my nephew. This is in Shannock. We're out there getting a Kenyan tan. If you don't know what that is, it's all the tanning in the water. You jump out, you look like you've had a really good day at the beach. But water's flowing. This is last weekend. It's great. I jumped in there. There's about a 30-foot hole there. It's really deep there. It's where DM built that wonderful boat launch with Wood Pawcatuck Watershed Association. So is there a problem? Not today. But I'm not planning for today, right? So it's all about trying to figure out how to educate folks, how to keep them going, understanding we've got to do a lot of legwork to be ready for that eventual drought. It's going to happen. I don't know when, but it will happen. So there it is. Save water, even though it's raining.